Hello everyone and welcome to Handmade Hero, a show where we code a complete game live on stream. And sometimes, as it happens, those of you watching out there at home in the comfort of your own living room or wherever you're watching this from, have some ideas that are better than my ideas when you're watching the stream. And I feel like that happened yesterday. At the very end of the stream, I was like, we got to align this thing, and maybe I need to sort of figure out some way to do an alignment update. And then in the Q&A, someone was just like, can't we just make sure this thing's always a multiple? And I had discounted that possibility in my head because I was thinking about it the wrong way. I was thinking like, well, I don't want to have to make the world chunks be a multiple of the lighting size. And then I was like, wait a minute, that's the wrong way to think of it. Just make the lighting size be a divider on the chunk size. That's what we should have done. It's okay, we didn't really spend hardly any time on it yesterday. It was only 10 minutes or 15 minutes or something. So I'm not going to lose sleep about it, but it is definitely true that was a case where the chat was on top of it and I wasn't. So let's take a look at what I'm saying for those of you just joining us. Inside the lighting code, there's something I want to do, which is that if you look here at the bottom of the sort of lighting solution work that we're doing, and this is kind of a big old gnarly struct that this will get sort of mushed down. There's a lot of crap in here that was just from experiments or that isn't relevant anymore. So I realize it's a mess to look at. That's okay. We're not going to clean any of this up until we're sure we've got the right solution. People who focus on clean code the entire time, you waste a lot of time of your time cleaning up code that shouldn't be cleaned up yet. And so, just to re-emphasize that, when you're doing experimentation, get the experiments working well first. Then clean up the code. Don't do it the other way around, because otherwise you end up wasting a lot of time. It already wastes a ton of time. Well, I shouldn't use the word waste. It's time well spent, but it takes a lot of time to do experimentation when you're exploring and trying to find a good solution to a problem. The last thing you want to do is strap another sort of slowdown or when you're running a marathon like that, you don't want to strap a refrigerator to your back. I don't know why I use that metaphor. My dad always used to say something about strapping a refrigerator back when running a marathon. I don't know why you can't do that. People can't even move if they have a refrigerator strapped there. It doesn't matter. Maybe one of those mini fridges that people use in college dorm rooms or hotels, the mini bar. Obviously without the stuff in it, because they have those weird sensors. When you pick up the thing, it charges to your hotel room in the minibar or whatever. So if you actually strapped one of those to your back, then as you were running, the jostling would probably make it so it kept thinking that you bought stuff from the minibar, and you would end up with like a huge bill by the time you got to the end of the marathon. And it seems to me that when you get to the end of the marathon, at very least, you should not have to pay, because you already did a tremendous amount of work just to run the marathon, and it's kind of like adding insult to injury. That's like, congratulations, you finished the marathon. Oh, by the way, now you have to pay the hotel like $170 because like the M&M peanuts like got bought 1,700 times or something, right? So if you take nothing else away from Handmade Hero, I would say don't buy things from the minibar. It's overpriced. Now, back to what I was talking about. We have this idea that we're going to store the voxel cells as a large sort of region around where the player is. And the reason for that is just that we want to be able to sort of cache lighting. And it may be a little inaccurate, but at least it's cached. And then as the player moves around, what we'll do is we'll sort of page in that section, sort of scroll it inside the voxel, if you will. And only in the center area of the voxel will we actually like update the lighting though. And it's true that this could have some negative artifacts, but with lighting, we're always going to have negative artifacts, artifacts that come from the fact that we can't solve the entire lighting every frame, because there's always going to be some lag, some lighting lag, and there's nothing we can do about that. But what we're trying to avoid here is the possibility that something scrolls into view and there's no lighting there, right? We would rather have the lighting be a little bit wrong because a light moved or turned off and it's a little bit wrong or something now. We would rather have that than it always be wrong, where we page we scroll fast and we end up seeing some area that hasn't had any lighting computations in a while. I would much rather not get there and go, okay, it's just black right now, and we have to like spend 20, 30 frames getting it back up to lit, right? So I would like the ability to cache voxel results as we move around. And so what I'm going to do is have a large voxel here that stores the lighting information in something much larger than what we actually transmit to the graphics card. So it is really just a buffer. We're not computing the lighting necessarily on this. We're literally just saying we're going to store a big region of the voxel cells. And then what we're going to do is say we've got a couple different things. We've got where the, in world space, in simulation space, where is the minimum corner? Where is the corner of the part we're actually doing? And then we have what its index is in the larger voxel. We have the dimensions of voxel cells, and then we have the storage for it itself. And then remember the hot voxel region, so the region that is the center of this larger voxel grid, the center part specifically, that part is what gets copied to the card, and it's actually used for render lookups. We won't copy the whole voxel because it's much larger than we actually need to compute the lighting. It's just a cache around that area. So where we left off yesterday, for those of you who did not see yesterday's stream, is when we actually go to do the begin lighting computation. You can see here we sort of had some stuff we were starting with. This is the part that we wanted to change. Instead of trying to align on every frame, we don't want to do that. We want to do this part right here. What I said, should we just divide world chunk diameters by some constants? The answer is yes. So when we init the lighting, what I'd like to do is I'd like to get that world chunk dim here. So basically, I'm going to demand that when we initialize the lighting, you tell me what the world is. And that way, when we look at the world, so you know, inside the world struct here, you can see that we've got this chunk dim in meters. So since we know that the world will be kind of aligned to that chunk dim in meters, at least for the most part, for the most part, we know that world positions, anyway, are aligned first to the chunk dim in meters with their int offsets, and then there's just a floating point offset on that. That makes it a lot easier for us to deal with origin P when it comes into the system inside begin lighting computation. So here what I would like to do is say, okay, we got this like chunk dim in meters situation here. And the problem that we would have with chunk dim in meters, I think, is that if you look, that's going to be here. Yeah. So if you look, what we end up with for the world chunk dim in meters is you can see that it would imply that our voxel would be non-uniform, right? Because if you look, you've got sort of a 17 times 1.4, a 9 times 1.4, and then the typical floor height bit here. Typical floor height, I don't really know what that's set to at the moment, but oh, duh. So it's literally set right there. I thought it was something that was get passed in, but it's not. So the typical floor height is like 5. These are like 1.4, right? And it's just like, we haven't really set ourselves up for success particularly well here because the factors don't seem to line up. Like these don't have a factor of 5 in them, and so they wouldn't be even with this. These both have a factor of 1.4, and so in theory, what we could do is say that that there has to be. I mean, we could do something like this, right? So let's say it is something like that. If we took a look at what the fundamental unit was, and we said this 1.4 for whatever reason, we could just set the typical floor height to be like slightly larger or slightly less large. So instead of 3.5, maybe it's just 3, you know? So maybe it's like 3 times the fundamental unit or something like this. And if we did that, then our lighting could be represented cleanly because each of these things divides evenly for the fundamental unit, right? It's 17 fundamental units across, 9 fundamental units down, and 3 fundamental units vertically, like in the Z direction, right? And maybe that's fine. right? Like maybe that totally works, or maybe that's a like horrible idea, and we have no idea. But it would let us align our voxels to the world better, and so let's just see if that's terrible or not. If I come in here to the world mode itself, so we're looking at this game mode world structure here, and I want to add this concept of fundamental unit, so we sort of have the typical floor height here. I don't know why that's stored in here, but we probably had a pretty good reason back in the day, because it needs to kind of be known elsewhere. But we got this typical floor height. So here we can also have the fundamental unit size, right? And then that way, that is just something that everything is created from. Now, I'm going to go ahead and if these out again as well. And we're going to have a problem here where our lighting is not actually working, right? And that's going to be an issue because we won't be able to see anything probably. But we could do maybe this. I don't know. Yeah, and you can see here, this wants to take the world. And so when we do our lighting initialization, we have the create world down here, and so we should be able to do our init lighting. Now, what we could do, though, is say, look, it doesn't really need to take the world. It could just take the fundamental unit, and that's actually a lot easier. So in here, we would just say, what's the fundamental unit? And that becomes our voxel dimension, right? So here we would just say, well, okay, you know, this cell dimension stuff, now we know exactly what it is. The cell dimension is always just the fundamental unit in all directions. So it's 1.4. That's the size of the voxel. You know, what are you going to do about it? We can also say that maybe it should have been 3 wide. Maybe 1.4 was not enough. So we could start with twice the fundamental unit as our voxel cell dim. Again, doesn't matter as long as an even multiple of the fundamental unit. I think we're probably okay. So we can certainly do something like this, and then we would be out of the business of having to do this modulus-based nonsense for our voxel. But again, let's just go ahead and see if this is sensible in terms of the way everything else works. I don't know. It might horribly break everything for all we know. Now, the problem is we don't have lighting in there at the moment because I've disabled it, and so we're just going to see a black screen, which is not so much what I would like. So what I'm going to do is inside the OpenGL renderer, just so I can verify that we didn't break everything horribly there, I'm going to go into the Z-Bias program here, and where we set up the lighting, I'm going to turn it off, right? So in here, I'm just going to say lighting disabled equals true. And we should probably hook that up to a more convenient debug key, so I can just toggle that on and off anytime we want, but we haven't quite gotten there yet. So we're not going to worry about that at the moment. So if you look at what we've got now, here is the version of this where we've changed the floor height a little bit. The floor heights are now less than they were before. And so we may have a couple issues with our world gen because I don't know if we really made that fully parametric. But it looks to me, right, like there's no real harm in that. You know, big deal. Right? Everything looks kind of fine. It looks like we have a little bit of an early alpha issue, but a lot of that's because we're still using the height of the player for the alpha fade, which I really didn't want to do. That's kind of just a bug that's been in there for a while, and we really don't want that. We sort of want more it to be based on the stable height of the player, so not like the hopping height, the ground point height. And so, you know, in fact, maybe let's just go fix that right now. But that's the only thing that looks like it's a little annoying. So we may also want to change, though, that threshold in addition, because we might be getting a little bit. In fact, you can see it's tuned a little bit wrong. Now, if I remember correctly, didn't we do this? You can see we've got an alpha min, alpha max there. So if you look, you can kind of see, this may be hard for the folks at home to see, and I apologize for that. But if you look at what the alpha level, you can see these like the black lines of just the very bottom of those cubes from the ceiling are visible That's again because the floor height is the alpha min alpha span is now tuned in properly. So you can see if I adjust this value using our real-time controls, right? You can see me kind of play with that. I think we want that to be somewhere more around 2 now, probably, or something like that. Let's just see if we can tune that value to something that we like better, and then we'll use it. So I think I like that. I think I like that maybe. So a 1.6 and then the 7.5 alpha span. So I'm going to go ahead and take a look at the alpha min default setting that we've got in there. I think I might go ahead and change that. You can see it's set to 275 here. I'm going to go ahead and change that alpha min to 1.6. Again, you can see how nice it is when you get those debug sliders working in there. Again, that's just a nice way of making sure that you always can tune the artistic elements of the game as necessary to make them work better without having to go through a lot of trial and error. It's just a nice little simplistic aspect of that. I'm seeing a little bit of alpha there, so I'm actually thinking maybe I was a little bit aggressive. So maybe 2 is actually a little bit more required. I will say it looks like that alpha is not based on Z. It looks like it's based on camera Z. No, it's not. So never mind. We did it correctly. But I guess, yeah, like I said, I see a little alpha coming in there, so I don't want any alpha on those bottom ones. So it maybe needs to be more like a 2.5. And that just clips out that ceiling. Or just, you know what? 2.25 seems pretty safe. All right. So I'm going to switch that to 2.25. And then I want to just go fix that bouncy bug because it bugs me. I really hate graphics glitches. You've seen me get annoyed on stream for stuff like that. And so even though I know that's not something that's probably that bad, it's not super okay with it. So anyway, I'm going to go take a look. I don't remember much about that code. So I just want to see. I'm assuming it's probably something to do with the code for update camera for entity movement. And so I don't know. I'm just going to take a quick look at it. But so you can see the focus min Z and max Z are basically like set from the room focus and the entity focus. So if we look at what the entity focus is, I just want to see what that is. Okay. So if you look here, you've got new target P minus entity PZ there for the entity focus Z. And the room focus Z is just whatever the distance is to the camera center. So I want to take a look. What is entity here? Is it just the entity? Yeah, so entity is just the thing that we're focusing on. And so you can see the fact that we're taking this new target P here, and it looks like what we're saying for entity focus Z is this is like the difference between the thing that the camera is focusing on and where the player is, right? That's all that is. And if we look, I guess we must use that entity Z value in a way that makes that make sense, because those are sort of measuring two different things here. Oh, because that's the new target P of the camera. No, that's fine. That's of the camera, not of the room. Okay, so we're good. So basically all we're saying here is, look, how far is the camera from the entity? All good. Problem is the entity hops around. And so what I want to do is go look and see, like, what do we do for get ground point? Or do we even have that? Like, how does the entity know where it is in terms of, like, hopping around and stuff like that? We need to figure that out, right? We need to sort of get that under control. So if we take a look at entity here, and we just want to make sure that we have some kind of a, a handle on its Z location, I feel like we need... It doesn't really look like we store... This must be why we didn't do it originally. It doesn't look like we really store information about where it was on the ground. So let me take a look just inside the entity code, that little like hopping code that we wrote. I just want to look and see how that's working. So if you look here at hopping, it looks like we just set the entity P between these two directly, right? So there's the two sim space traversables, yeah. So I feel like we kind of need to store a little bit of extra data here, because this is how we're keeping this information. It's implicit in the to and from, and so we kind of need to be able to project it back down onto that vector, if that makes sense. So I would say we need something like, when we're planted, the entity P just is what it is, right? So like, entity ground P equals entity P or something like that. So this is like the stable version. Although come to think of it, even this is not quite right, because as you hop around, there's sort of you're sort of moving at different heights if the ground is uneven. So, but that's probably okay. So let's say that we do it this way, where we have a ground P that we update, and it's just whatever the entity's actual placement is. And then when we are doing anything where you might actually have a hop of some kind there, what I'd like to do is set this up so that we are properly doing that projection. So here it looks like when we're doing movement to and movement from, right? This should be pretty straightforward. Yeah, it is. If you look at this, right, all we really need to do here is there's like the hopping, like the height displacement. So it's this right here is like the height displacement. It's the Z displacement, right? And so this is just a parabola between these points. And if you look at sort of the parabolic arc here, the B function, which is just linear between the two, if we want to, we can just compute that actual linear quantity and use that directly to update the position. So in terms of the entity like ground P here, it's actually quite simple. It's just the lerp between these two based on T. So what do we call this? Is it lerp? It's just lerp. So if we want to, we can just say there's a movement from and a movement to, and we're going to lerp those for the ground P in that case, but in that case only for a hopping entity. I think that's all we really need, right? And so I think that that's probably sufficient. I don't know that ground P needs to be saved because it's derived from the other information, so we can probably just stick it in the part that's only for active entities that are in the cache. Seems plausible to me anyway. And yeah, obviously we have to recompile. We're changing the layout of a fundamental structure there, so that's not going to fly. All right, so now in theory, I think we should have stable ground projection. So when we hop down the stairs, we should now see a smooth descent through the alpha. And I'm totally wrong about that, apparently. Oh. Yeah, so it turns out one thing you should do is if you go through the trouble of computing this value, you should actually use it. I don't know how many times I've done that on Anime Hero where I'm like, and so we will use this thing, and then we don't use the thing. So yeah, obviously I was trying to compute a different value to use for that expression, never actually used it in that expression, so it's not a surprise. Let's try that one more time. Hopefully we'll get a better result now. So here is this hopping around. We're going to go ahead and go down the stairs here. And so let's give that a shot. And so, you know, we do get from the height variance, like the fact that this is higher than that, we get a little bit of variance there. So, you know, I don't know if we want to try and clamp to an actual floor level or something like that. You know, we certainly could, and that's something we can think about a little bit later. We could store, for example, with our interpolation points, we could store a ground P value with those interpolation points. So the actual traversables, right? The hopping locations. We could store something that told us about that and then interpolate that for stable. I don't know if we want to go that far with it. That's a tough call. Probably we do want to go that far with it. But at least we've gotten rid of most of the ejectional artifact there, so I'll save that part for another day. Because, you know, what we would do is we would just go and say that there's a ground P value. Well, you know what? I'm sorry. It's just, these things really bug me, and there's not much I can do about it. But let me just take a look at what that would look like. So in the entity code, when we're doing the hopping calculation, when you get this sim space traversable, right? You can see it doing this get entity by ID, and then it looks at whichever traversable is on that particular entity, right? Which, by the way, I'm not sure why we did it that way instead of just making traversals be their own entities. Probably not something we want to do. So yeah, what we would probably do is, in the future, I think we would probably say that these will be their own entities, and we'll probably just use parenting to move them around. That would be my suspicion. Yeah, so looking at this, I think there's a couple things we want to do, and I'm going to make some notes up here on these. So in the entity itself, I think what we want to do is say, okay, I think we want to say and the last thing is I think we want to make these changes, but I'm going to do that more towards the gameplay code side of things. I think we want to do that later, but I do want to do it, is all I'm saying. So let's get back to the lighting code now. Yeah, I think, like I said, setting that fundamental unit just seems like the right thing, because there's really no harm in it, and it seems like everything works just fine. There's no weirdness to having the floor heights be smaller. So everything's just dandy, I think. And if you look at this, it fits nicely in there. It doesn't look like the floors are too small. If anything, that's probably a little bit better than it was before. So I'm totally fine with that. Alrighty then. So coming back to the lighting code, that means that this is now basically all correct in terms of setting the voxel cell dimensions and all that good stuff. When we go into begin lighting computation here, what we want to do is we want to go ahead and take the part we were going to do with the modulus before. And what we know is that the world position now, that part we don't really care about as much, right? The world position is not super important to us anymore. What we really, because we know that the sort of numerical version of that, go ahead and jump over here. The chunk X, chunk Y, and chunk Z, we know those are now correctly aligned to the lighting voxel automatically. So it's really only this part that's not aligned, if that makes sense. So that's the only part we really have to worry about aligning versus, so we can kind of come up with a composite offset there, right? Where we say if this is the origin P and this is the offset from the chunk center where this world position actually is, then if we wanted to figure out where this camera offset origin was in terms of its relative position, we would just have to use this offset manually, and we know that these parts are aligned, right? So what we have to do now is start to get these voxels placed in the correct way. I would like to be able to sort of draw this region a little bit. So what I want to do here, if possible, is go into the world mode, and we have the sort of volume outline stuff, right? And what I'd like to do is draw this in here. So I want to draw two things. I want to draw the region that we're actually going to light. So I want to draw like the large voxel and then the hot voxel, right? So I want to have a large voxel rect and a hot voxel rect. And I want to draw like the large voxel rect as one thing, and the hot voxel rect as another thing. And now I want to be able to like hop the dude around, and I want to see them move correctly, because there's a lot of stuff we can get wrong in here. It's going to be a pretty finicky computation. So rather than try to get it working all at once, I just want to get the visual version working so I know it's right. And then we move on to actually using it for lighting. Again, always breaking the problem down as much as I can into smaller verifiable chunks, because especially with something like lighting where it's very hard sometimes to tell what's going on when you look at it, you want as much as possible to break it down into pieces that you have some chance of getting a thumbs up or thumbs down on clearly, rather than like, looks kind of like it's working, I don't know. That's not a good place to be, because small bugs compound there, right? All right. So what I now want to do is try and figure out the rest of this information. So inside the lighting solution, right? We do want to keep an old value for the world, for like where we're aligning our large voxel. But I'm not going to do that yet, because before we do anything that keeps an old one, we want to do something that figures out where the new one is. And so I'm going to go ahead and do just that part first, and then we'll worry about updating the voxel for motion a little bit later on. All right, so we need to come up with two things. We need a rectangle 3 for large voxel rect, and this needs to be something, and then we need the hot voxel rect. Now, if we have the large voxel rect, it should be pretty easy to come up with the hot voxel rect, right? Because the hot voxel rect is pretty simple. It's just going to be, well, and I guess in some sense both of these are very simple, but I guess what I mean is the vox min corner hot part, we kind of know what it is because it's a fixed offset away from the larger one. Or alternatively, if we want to phrase it the opposite way around, we could just say, once we know where the hot one is, we know where the large one is. So we really only need to compute one or the other because they're locked to each other. And so it should be a straightforward equation to get one once we know the other one, right? But computing the first one is what will be hard because it requires that alignment calculation. Okay. So we know that in order to do the hot versus the large, these are both going to start with whatever we compute the corners to be up above, and then we sort of got some ancillary information that has to be computed here. We'll go ahead and set that up, but I want to start naming these things more appropriately, because if you look at what these are named, light dim, inv light dim, not helpful. What we want to say is this is the hot dim versus the large dim. So let's just make sure that that's clear. So here we say, all right, we've got a hot cell count here. Oops. So that's how many. That's how big the sort of hot version is this way. So the dimension of that is going to be the hot cell count times the voxel cell dim. Again, voxel dim, same between the two. So the inverse of that, right, is just 1 over it. So all that stuff remains the same. And then here we're just going to say, all right, so this is the large dim and this is the hot dim, right? So now we're down to like, okay, what's the large dim? How is that specified? Again, pretty straightforward. All we really need to do here is figure out what, back here we got the light large voxel dim. We can do large cell count like so. And then we can compute these same two values. Now we don't need this one necessarily, at least not at the moment, so we're not going to compute it till we know we actually need it. So we really just have large cell count times that voxel dim. So now we've got all of that is pretty much correct, right? And what you can see breaking down here is most of this stuff is just known. So all of this is like a no-brainer, right? That's just right off the bat without doing any calculations really. We can compute all of those values just from what are effectively constants really, right? And so when you look at the actual hard part of the computation, the part that's going to be finicky is computing one of these two corners. And again, once we get one of the corners, the other one will follow suit. So what I'm going to do is say, look, the hot voxel is the one that actually matters. The hot voxel is the one that actually has to be fit to the camera, and it's going to require a lot of sort of funky sauce there to make that be a reasonable equation that always gives us, a reasonable expression that always gives us something that covers the area properly and doesn't, because before we were sort of doing stuff as like, let's look at the camera frustum and what's it doing. We can't really do that because we don't want this thing to shift around. So what we kind of have to do is go, what's the maximum amount we're ever going to zoom out and make that lighting capture that, right? And then when we zoom in, we need it to stay the same. So we have to kind of do some more aggressive positioning here. We can't just use camera information directly. So it's going to be a little bit of work to make this go, right? I think we need one more piece of information here too, which is like the target location, like what the camera's actually looking at, right? So anyway, if we want to continue down this path, let's compute this one. So that means now I think I can also down here before we go past it, I can write an expression that gives me the large voxel corner from the hot voxel corner. And the reason that I think that's easy is because we've sort of already said that there's a fixed displacement between these two things. So the hot corner I, for example, will probably just be something we set in here. It's not going to be dynamic. It's just going to be something that says, where does the hot voxel live inside the larger voxel? So the hot corner I is a pretty easy thing, I think, for us to do. Oops. All we need to say is, look, what's the actual dimensions of these various voxels, right? And that will tell us where they go. In fact, I can even do this dynamically in case we do want to allow the lighting voxel to be different dimensions at runtime. I don't know that we ever actually want that. But you can imagine doing that, because if you assume that you have the large cell count and the hot cell count, that's more or less all you really need to know. Because if you think of what we're doing, we have the large cell count, which is a bigger number than hot cell count. It's like 128. And hot cell count is like 16, right? So what we want to do is say, if we have a 16 in the middle of a 128, how do we figure out where that's aligned? Well, pretty straightforwardly, we can just say, let's remove the hot cell count from the large cell count, right? So we would say something like this. So we'd say, this is how many cells are left over on either side, right? So if we divided this by 2, right, we would get how many large cells there should be like on the left of the hot cell count, and how many there should be on the right of the count, right? Roughly speaking. So that tells us where the hot corner should be if we just use that offset. That tells us how far we would go to get to where, if we wanted to roughly center the hot cell count inside the large cell count. That's all we really need, right? Because that's how many you would go to get roughly halfway to where this thing is, right? And we don't want to go the whole way, because that would push it all the way to the end, right? And we want it in the middle, so we're dividing by 2 so that we put the same on either side of the hot cell count. So computing the hot corner I, very simple, right? So once we have the hot corner I, all we need to do then is say, well, from the min corner, if we just go backwards, however much that is, that's all we need, right? So the Hadamard product, just of how many cells we need to go, the Hadamard product of that, like so, or is this just this now, I think. The Hadamard product of that with whatever the cell dimension actually is, right, is all we need, I think, right? There shouldn't really be anything else involved. So once we have all of those computed, then we're just at a point where, yeah, now we need to, okay, so we don't know, we do have the render group. I was like, we need the render group in here. There we go. So once we have all that, the only thing that's missing now is just that anchor point. We just need one point in space, and we've computed everything else for our entire voxel system from that point in space. We now need to get that point in space. We need to find that point in space, and that's where we're at. Now let's make sure that all of this stuff is set up properly as well. So we should have no compiler errors now. And the only problem that we have now with our voxel is the voxel's just not, it's not centered, right? So it's always going to be at 0, the hot voxel corner is always going to be at 0, 0, 0, which we know is not correct, right? But if we actually look at it, you can see we've got it now, right? We actually do have it there. And you can see it's sort of aligned in the middle as well. So it's exactly what we would have wanted, right? It looks exactly right. Now, one thing I would say is something seems off about the dimensions of the voxel. That looks too large, potentially. No, actually, it might not. When you think about zooming out to that thing, maybe it's not. It might be a little bit. But let's see what happens if we change the fundamental unit scalar there. So I'm just curious. Let's suppose I go into this system during init time and say the fundamental unit it's 1 long instead, right? I'm not sure that might not be good, but that might be too small now, right? But that's what that would look like, and that looks like a little bit better bounce. I'm just not sure. This might not be quite enough. When you look at what happens when we sort of hop into, let's say, this other region over here, right? I'm just not sure that that's enough lighting information necessarily. It might be a little too small. And so that's the only sort of squinky bit. Maybe we do want it the 2. Maybe we want it the 1. I really don't know. So let's go ahead and just try to get a little bit of a better feel for this. So in here, let's make one small change just so we can get a more ballpark feel for whether it's too big or too small or whatever else. If I take the Vox min corner hot and I just say, yeah, I'm going to place that at, I'm going to shift its dim sort of back a bit. So I'm going to compute this first, and I'm going to say that it's going to be the negative hot voxel rect minimum, or rather dimension. Oh, actually, never mind. I don't need that. I just need hot dim. I'm just going to go back by half the hot dimension. So I'm basically shifting this back. I'm going to shift it over this way just to see what that looks like when it lines up with the simulation center properly. Because this is roughly what we actually are trying to compute right here. So if I look at what's in the view right now, you can see that if I were to actually track the exact target, it looks like that would be potentially enough lighting. Would it? Not on the end, though. So not quite, right? It's a little too small for that zoom level. You know what I'm saying to you? So it seems like we do actually need it to be twice the fundamental unit. And I don't know if that means we're going to have to make the fundamental unit be something that's half of that value. I'm not sure. We'll see in a second. Let's try this again. And so that's a much cleaner encapsulation. That gets everything. I think that's what I want to use for the lighting. I think seeing it centered around here, it's like, yeah, that's probably right. You know what I'm saying? And what we can do if we need to, if that's not resolute enough, right? So if that's not an acceptable amount for the lighting, what we can do is we can go ahead and increase our voxel resolution by 2x, because we know right now it's 16 by 16 by 16. We know we can go to 32 by 32 by 32, no worries. So we can play with that value a little bit and make sure that that works okay. So let's check that, and then I'm going to move forward with this. I think we're in the ballpark of where we want to be. So I'm not too worried about that. So I'm going to switch to test light checkerboard. I'm going to turn the lighting back on. And so in compile zbias program, I'm going to get rid of that lighting disable. And then we should see the checkerboard light and roughly like how big that checkerboard pattern ends up being will give us a little bit of an indication of how resolute the actual lighting is, right? And like I said, I think it's going to be a little bit too sparse, right? In fact, I'm pretty sure that's too sparse. So what I want to do there, this gives us pretty much the information that we needed. What I want to do there is kind of scale things back a little bit, push them around a little bit. I'm going to say that we're going to make this be a +1, and I'm going to say that we're going to make the renderer version, instead of 16, it is going to be 5. So it's going to look like that. And then we can go ahead and back off of that scalar, because now the hot region could be one, it will actually be one fundamental unit each time, right? So instead of this, it will now be that. So that just ups the resolution of the voxel. And then I think we're probably where we want to be. We'll double check in a second, but I think that's roughly okay, right? So now let's take a look at how the voxel aligns. Here's a more sort of dense packing. You can see the stripes. They seem better now. Why I'm not seeing the blue stripe very well, I'm not sure. Probably because this is green, so there's not a lot of ability to show any of the stripes there. But yeah, so I'm not sure about why we're not getting. Oh no, you know what? The reason is because I don't know what the reason is because. Is our checker pattern busted? Hold on a second. Everybody just hold your horses. I want to go in and see in test checkerboard. Here it is. I want to go and see what the problem is here. So maybe something more like this. So now that's more of a checkerboard, and it's an actual checkerboard pattern. So in fact, I like that a lot better because I can see it really clearly now. And furthermore, you can see that areas with lines are areas that are outside the region, which I like. You can see right on the boundary, it changed from the checkerboard to just a clamped pattern. And I like that because before it was kind of hard to see what was happening there, but now it's not, right? So now we can see the relative resolution of the lighting in here. That looks pretty good to me. I don't think we're going to need more than that because, again, the quality of our lighting transport is not going to be, you know, like super resolute. This isn't, you know, hardware ray tracing or something. So we know we're not going to get any kind of spectacular levels of light transport fidelity. So we probably don't need our voxel to be like Mr. Awesome Voxel. Because at some level it's not going to have that good of lighting information to start with. We don't need super great interpolation on a voxel that doesn't actually have particularly good fidelity in the first place. Looking at the vertical resolution is a little bit hard here. So I'm having a hard time really telling like what the... I'm having a hard time telling exactly what's going on there. You can see there's blue and not blue, but it's not very clear. So I think what I would like to do here is maybe try and alternate some color pattern to make it a little easier to see. Maybe we'll try to alternate between like a blue and a green or something. I'm not sure. I'm just trying to see if that would make it a little bit easier for me to see what was going on. It probably won't. I mean, you can sort of see as you get up to the top of that blue, you know, maybe. But then it's really hard to see the checkerboard pattern, right, as well. So if we wanted to make the checkerboard pattern be in all dimensions, can you just do this? I'm not actually sure. I've never thought about this before. But if we just wanted something like this, so we have like full bright and then, you know, dim. That did not work well. I'm trying to think of what the right answer is there. So normally if you want to do a checkerboard, you'd have this first one, right? So you'd just say if X, I guess you just want to invert the pattern as you go up and down. You know what I might also do just so we can get this pattern properly? In the OpenGL series, I would want to go ahead and, when we initialize that texture, I'd want to set the texture to be non-linear. So I want it to do nearest lookups. So like, for example, let's see here, that'd be right. Right here. So here where we do the color interpolations, I would just set this to nearest. So for the checkerboard, I guess all I want to do is on the Z plane, I just want to flip it. So I would just want to do like one wave. It's sort of an XOR, right? So there's the lighting checkerboard, and that's much easier to see, right? That's what I wanted. So that's pretty easy to see. And then I would like it to be that I could also see it this way, right? Like I'd like to be able to see it up and down as well. And I suppose that part of the problem is this lighting normal should also kind of be something that can be sort of placed. In fact, I could do this. So I want to be able to look at least at one side of walls so I can see them get checkerboarded as well. So like, for example, you look at this. And so now what I want is I want to be able to look at that checkerboard. I want to see how many vertical resolutions I get as well. Now, I can sort of tell because I know that this is cubic, right? I know that we're not, the voxel cells are cubes, not right rectangular prisms. So I can understand the size roughly by saying, well, it's that big and it going down. But I would like to just see it for myself. So what I want to do here is say, well, okay, so we've got X mod 2 and Y mod 2. Another way of saying that is just this, right? Like if the low bit is set, right? Oops. Finish, please. Compiles take too long in release mode. So this is another way of saying that. So we should now be able to get the same result here, right? And so if I have X mod 1 not equal to X mod 1, that's just an exclusive OR, right? In other words, if I want to say I only want the thing to be true if these are different, it's just that, right? That's the entirety of the expression. And so then if I want to make it so that it goes the opposite way depending on Z, I should be able to just XOR Z in as well, right? Like I should be able to say whatever Z is, well, just toggle it based on that as well, right? It should flip it. Yeah, there we go. So there's our three-dimensional checkerboard, and now you can really see like where all the lighting cells are. And I guess what I would say is my only objection is we probably want this to be shifted, because if you look, well, we don't need it to necessarily be shifted. When we place our lighting probes and our lighting grid, we want the probes to probably be placed in locations that are not right on the edge of a grid, but I don't actually know if that's true. We'll have to see, but it's something to be aware of. Anyway, so looking at this, you can see where the active lighting region is. It nicely encapsulates everything that could be involved. When we're zoomed in here, we should now never really see the checkerboard stop. There should always be a checkerboard everywhere we go. And I think that should be just about it, right? Now, looking at it the way it is now, I would almost say, gosh, with the lighting region that encompassing, we may be able to just not bother with anything else yet anyway. Because that's pretty much just fine, right? Like, that just works. And if it's always centered around the simulation center, we're pretty much good to go. The only thing we have to do is make sure we handle the simulation center possibly having an offset there. But otherwise, this really just doesn't shift. It's pretty much locked to where the cells are, and that's all I really wanted to make sure it would do, right? I wanted to make sure that it wouldn't slide around relative to that and cause artifacts. So we might be able to just leave this as it is temporarily and revisit it later when we actually have a case that doesn't work or something. But that seems pretty good in terms of where the voxels are. So it's kind of like where the wild things are, right? So I think that's all right. If we then move forward with what we're doing, and we go ahead and set the transfer lighting version. So in here, I'm going to say test light transfer. And you know what I could do? I could just make this easier on myself. This way we just toggle which one it is. So if we actually go ahead and set back to the transfer version now, what I want to do is try and figure out a way to get our sphere lighting happening using the transfer system. And I don't remember where we left that, but you can see there's nothing on the screen right now, so our lighting's not really doing anything. So the first thing we need to do is now get that version working. And we know that now our actual voxel values are not garbage, right? They're actually set to something, right? So what I want to do is now have that something actually create valid lighting values by going through the large voxel to the small voxel. So here is a loop that loops over the voxel dimension. Unfortunately, if you look at what's happening here, this is not correct. This is, and that's again, it's because we have this concept of voxdim. Voxdim is not good. It's ambiguous. We want to start talking about these things more concretely. So what we want to do is take a look at the nomenclature where we've got hot and large and make that be sort of the more appropriate nomenclature here, right? So when we set this up, and we go like this, now we know what the hot and the large dims are, and now we can make sure that these two loops actually operate on values that are correct for the thing that was trying to be expressed. And we can set the inverse dimension up here for the hot version. I don't know that we actually need that later, but at least for our old test code, we need it. Now in here where we're doing the this initial setup, this is supposed to be looping over the large voxel. You can see that happening here. So this is a large dim loop. That's going over the 128 by 128 voxel. Here we're going over the small interior version. So that's the hot voxel, like so. And so in here where we're doing these old tests, this is like the inv hot dim. So things that we're operating in here that need to talk about dimensions there, they have to be using hot dim. All right. So if we look at this indexing here, this is just saying where inside these we're going to be. Again, that's going to be hot dimmed all the way as well. So let's get that started. And then I think that might be it, actually. And so then we can start working on the transfer code and getting that working properly. So all right. So I think now have the loops right, but we're going to have to actually figure out how to get the transfer working. If you look at the transfer, you can see us just looking up the displaced version. So that's Z, Y, and X there. The displaced version of the hot voxel. This is us packing all the values in there, as we would expect to do. And then they're just going to get shoved into the voxels that voxels actually used for lighting at hopefully the correct location. So that's all we really need. And so the problem is just probably in here or somewhere we're not actually stuffing these values correctly, or who knows what, but we're doing something wrong. And so we need to figure out like why we're screwing this up. Here's us looping over the large dimension and filling out each of the cells. You can see us using Z, Y, X, which I believe is the way that the transfer is working. There's it doing a Z, Y, X extraction of the sort of sub-region of the grid. It's using N0 through 3 and C0 through 3. So the question is, are we setting those? You can see us setting two of them anyway, the 0 C value, the 0 N value. Those are the two we're trying to get happening here. Looking at what the actual values that are coming through, the question is, why aren't we seeing anything at all? I'm not quite sure. Feels like we should be. And so something's a little bit up. Looking at the fall off here, So I don't really see anything obviously wrong. Yeah, so I'm not quite sure what's going on there. I don't really see anything immediately wrong. Um, so I may say let's take a step back. Let's just first play with this a little. So suppose I was to nerf this stuff temporarily, and just use the checkerboard pattern on the whole voxel, right? And so we're going to set the light C0 here, and that irradiance pack, let me just make sure I understand what irradiance pack is doing. Yeah, that just takes the light value. So if we were to just say, let's put a bright value in there, so we're going to say that like our light C is just going to be nothing. In here we'll say that our light C0 is going to be some bright light, like, 5 or 1. Which the max light intensity, so 6 times the light, I don't know what the max light intensity wants to be here, but, who knows? I don't know. It's something. You can see the irradiance pack, what it actually does is it looks at the max value and then scales it by, dividing by the max light intensity. So we can have values pretty high here, right? I mean, these could be who knows what. They can be quite a bit, right? So who knows what we set this to? Something like this. Maybe. And I just want to see, can I make the checkerboard, like, why are we getting nothing, right? Like, I don't know why I'm not seeing anything at all. And so I want to just start by saying, is the transfer that copies from the large voxel to the graphics output routine correct? And, that looks like it is to a certain extent. If I go in here and set this to 5, what do I see? So I'm kind of not sure why we're getting such a steep fall there. I think we may have some bugs in our irradiance code. Let's take a look at this. So what we're doing here is we're creating a result value. First, we look at what the highest value of any light intensity is, assuming there's any at all. We then scale all the light values, right, such that what we're going to multiply by is some fraction of the maximum light intensity value. Well, actually, so we scale the colors so we know that the brightest color channel is 1 and everything else is a proportion of that, right? And that's what this does. Then we set the intensity to be whatever this max value was divided by the max light intensity. So that's the alpha unpack, right? And then we pack all that crap together, right? That's just a BGRA pack 4x8. And I guess it's worth noting that that stuff is not gamma corrected. Right? So one problem that we will have is none of that was gamma corrected. So it's actually not going to be right when we unpack it if it was a gamma texture, right? If it was an sRGB texture. So what did we actually tell it that it was? Okay, so it's not, it's just straight RGB, right? So that seems good to me. So that seems fine. Let's take a look at our ZVias program where we actually unpack the light and see what we get there. Oh, right, and so our max light intensity, yeah, this is all just kind of wonky now because since it's actually negative 1 to 1, it means anything less than half the max light intensity just wouldn't show up, right? Interesting. So basically, like, yeah, we need to fix that as well. Because it's a full binormal and it should not be. So that was probably the entire problem, right? Now that seems bad. Where did our voxel go? How come I'm not seeing any? Oh, because it does misalign itself sometimes. There's an example of it misaligning itself. Now, like it's on half alignment here, and it's on whole alignment. So we will need to fix that, and that's good. We have a test case now. That is unaligned, that is aligned, right? So that's good. All right, so that was probably most of our problem. It's probably just that this is not creating enough of a light value, and you can actually, yeah, in fact, this was just garbage. So I feel like we're going to have to work on our max light intensity encoding in a second here. That's going to have to happen because it's pretty much garbage at the moment. And you can see we have a to-do there for it, in fact, as well. So when we look at what the light C is and it's clamping negative 1 to 1, this is all just complete garbage. And when we actually go to do that packing of the lighting, this is not going to be correct. So what we want to do instead here probably is we probably just want to say like, all right, this is the fall off value. So the fall off value is like going to be something where we just do like a lerp between the maximum light intensity and the minimum light intensity. So it's like max light intensity, you know, half and whole, something like that. Alternatively, we can just do it, you know, with these two values here. So whatever the zero value basically is. You know, we could do something like that. And I don't know why we're calling this light C. Yeah, there's so many weird things in this code. Let's clean this up. This is just ridiculous. This is the light distance, right? This is the light like intensity value basically, right? Like this is the distance fall off, right? And so here where we do the light alpha value, again, doesn't really make any sense the way that we're doing this exactly. Because the way that these get packed down is they're getting packed down using the max intensity. So again, all of this stuff is kind of busted from where it probably should be. So this is not what this light alpha is totally wrong. The light alpha wants to be a lerp between, like, say, you know, half the max light intensity and, you know, 7.5 times the max light intensity or something like that based on the distance fall off, right? That's what would actually give us usable values. And then the light actually now does have a correct color. So if we were to look at that, now maybe we would see a proper spotlight. And in fact, we do, right? So it was just again, that was just the encoding problem. So again, looks pretty good. Let's go ahead and turn back on our linear and see how we do on that. What I would expect now is a nice, clean version, very similar to the one we had before. And now we're set up more to start doing our transport, right? So if we go ahead and change back I really need a hotkey for some of these things. One of these days we have to do a quality of life improvements thing, so we can just toggle these really quickly, because it's really important to be able to see these, and I have to keep going back to the code to change them. I don't want to have to go into the code to change them. I would rather just be able to just quickly hit a key and toggle between them without having to find any code. So there's our interpolation, right? And you can, in fact, we could even stop it from hopping up and down if we wanted to by making it use the ground P now, which might be nice. But anyway, you can kind of see us moving that around there, and that looks pretty nice. And again, we get really, really good radial. Again, from such a small voxel, it still reconstructs the edges perfectly because of the sign distance field encoding, which is pretty good. And then what I want to do now is say, all right, let's try to start extending this by actually doing some casting in the voxel. So what if I wanted to say, can I see the light source, right? So where's that raycast? Here it is. So if I was to call raycast and say, you know, give me back what I hit. Just literally that, right? So if I was in here when we're going to do this light alpha, what if I just called raycast on it, just for purely for amusement purposes? And I guess I don't know, what does the work function do? It's just a way of having the solution here. Okay. So if I was to say like, all right, there's a lighting work thing, and I'm going to just like initialize that. And what does that have in it? Oops. So it's just got this. So if I just want, I don't care about any of this stuff. So if I just want that, and I want to go ahead and do a raycast on that, let's try and get that working now. So we know where the ray origin is, or you know, it depends on how we want to look at it. But what we could say is, look, the origin is going to be, we're going to cast a ray from the voxel center. We're going to cast it in the direction of the light. And I just want to know if we got to the light or not. Like, that's all I wanted to know. So if I look back at the raycast result here, right, then what I want to know is this, is the value, is the t value basically that I would receive, is that going to be closer or further away than is the first thing I hit further than the light that I was trying to hit or not, right? And I don't know what hit is here. Is that like just a Boolean value, or is that actually like, I don't know. I have to go look at what we set that to. So let's see, when we're actually tracking hits in here, so it looks to me like hit is just a test on T-ray. And I'll be honest, I'm not sure why we don't just return the T-ray value, but it seems like we should just return the min T-ray value here. But hard to say. So when we do the raycast here, we need the origin and the ray distance, right? And in this case, I'm just trying to do a single raycast. I'm not trying to do this actually quickly. So what I want to do is I want to sort of generate one of these by lofting up one into just a 4-wide version of itself, which I'm assuming we have a way of doing. I don't actually know, but we would in theory have, right? I'm assuming we can do something like this. So I can say like Vox center P4, right? And light N4. And that just does the same raycast 4 times. Because, hey, it's the same cost as doing it once. So who cares? But like normally we would want to pack multiple things in here, right? And so let's see if we can just get that working, and then we'll kind of end there for the day. And then next weekend we can start to work on the actual light transport code. So here we have the cast value. The cast value gets back, like I said, it's got this sort of hit and p values. I just want to look at one of these. So looking at the actual structure for this thing, I kind of want to extract a single v3 from it, and I'm not sure what the easiest way, oops, that was not what I wanted. I'm not sure what the easiest way to do that is, because I don't remember how we set this up exactly. So I don't know what we use for extraction here. Here it is. So assuming I just want one of these things, I can just say, look, why don't you give me back the 0th answer? That's fine with me. So I'm going to say, like, here's where the hit P was, right? And I can also ask if there actually was a hit there, right? I should be able to use a mask version. And in fact, I guess I can just look at where we were calling this before, and presumably, like, the extraction stuff was there. I don't know why I didn't look at there first. But inside compute light propagation, right, we set up this light work stuff. And then in here you can see us doing the tests. So it looks like I can just literally do this. So all I want to do is say, if we hit something, then I want to test to see how far away it actually was, right? And again, that's why I would have wanted that T-ray value, because I want to just be able to look and see, is it longer than light dist? But it's okay. I don't really need to know one way or the other, I guess. So that cast P value that we get out here, I can just compare that with the actual light position. So what I can do is say here, if the inner product I can say if the inner product of the thing I hit minus the place I'm casting from, so that's the Vox center P, right? If the inner product of that along the direction I was casting is less than the distance to the actual light. So in this case, I've got the light P minus the Vox center P, right? And I already did that effectively because I took the length of that to compute light distance, so it's that. So if I hit something closer than the light source, then I would just say, let's set the light C0 to its minimum value. And I can do that a little bit easier by moving this stuff down below. So where we go here, I can do that, right? And this light DF value, which we've computed ranging from sort of a clamped version. I should clamp this, shouldn't I? That should have been a clamp 0 to 1. I lost my clamp in there. Right. In here, what I'll do is I'll muck with that value. But first, I want to make sure that my clamp didn't screw anything up. There needed to be a clamp in there, and there wasn't. So let's make sure that works. Also, this is just cast and 0. So then we will just see, and our rate casting code may have been borked because, again, we were mucking with it and haven't tested it since then. So I don't necessarily expect this to work, but I just wanted to get this in there, and then that sets us up for next weekend where we can start playing with the raycaster and getting that solid. All right, so in here, what I do is say, all right, let's just set the light DF down to some negative value. So this is, going to be where the field falls off steeply at this point. So, deal with it, and we'll just go from there. Now, I don't expect this to necessarily work, so who knows what this will do? Probably nothing. Looks like, well, that's kind of weird. I don't know what that exactly, it looks like the raycaster is returning hits for things out here, but not for in here or something. Not quite sure what that's doing. But it's doing something around the edges. For some reason, I'm not sure. And again, like, we haven't really looked at this function in a while. And it's probably a little bit busty. It's just a busted function. Not sure I want to dive in here because we probably got a bunch of things to do. But I just wanted to look and see if there's anything obvious that I was like doing. Where I was misinterpreting what it's actually doing. That seems reasonable. I don't see anything completely ridiculous here. It looks like I already had that comment in here. See, I don't know. I don't know what's going on there. Is cast P set? What is cast P set from? Because I also don't really know how we're setting that, what that actually means. Like, where is that getting set and why? So, result P equals hit P. And so that's just, yeah, so that's just T-ray times the ray distance. So that is literally just, yeah, taking T-ray and moving it. So, this should be roughly correct, I think. And we are only going on things that are valid, like greater than valid values. Yeah, I don't know. The close enough thing might also be a problem for us here, because that is the thing that I think lets us say that the box is kind of like if I were to turn that off, right? So when we do T close enough and we're checking to see whether we can use a larger bound, like a thing that doesn't actually continue to raycast. I'm curious if we were to look at that, is that causing a problem here? I don't think so, because 10 meters is further than I think where we were seeing the weird sort of artifact around the ring. But in terms of saying, like, is it less than close enough? So in there, I wonder if I just said, like, look, that's going to be a lot higher. I'm assuming that doesn't really help us, right? Fix the weird... I just have no idea what's producing that result, so I'm kind of curious, to be completely honest. Yeah, and it has nothing to do with that, it looks like. So, I want to end the stream, but my curiosity gets the better of me. I want to know what that artifact is, and it's hard for me to not know. I'm assuming that this is the entirety of it, meaning if I remove that, I would get my perfect circle back. Oh, no, I don't. Okay. So it was something else. What was the something else? Right. This has to go below 0. And 0 is half the light intensity. So that was all. Yeah. Okay, so at least now we know that the raycasting code is not actually producing that artifact. Whew. That was going to drive me nuts. So very good. And so what it looks like here is if we were to set the light DF to 0, in that, what it really looks like is going on, the only thing that looks like it's happening is the raycasting code is never hitting anything, right? I mean, that seems like roughly what we're seeing. And to be fair, I guess I don't really know how high up that light is, but you know, like regardless of how high up it is, I think it probably should have been hitting something. And so I think that code's just not hitting anything would be my guess. I don't know if maybe we nerfed the call that builds the bounds. That might also do it. But I guess I could also look to see. So if we're like here, are we prevented from hitting stuff below? We're not. I mean, we're totally hitting it. So let me just double check that we're calling it, because like I said, my curiosity always gets the better of me. I'm supposed to be ending the stream, but sometimes I just don't. And that's just the way it goes. So in here where we do compute light propagation, we don't set anything up there, I don't think. So I think the only thing that we would have to do is when we actually call the start of this stuff, we have to build the actual spatial partition, but that's it. So build spatial partition for lighting. That's the thing that actually has to, okay. So we need to actually build the spatial partition. That may be 90% of it, but we still don't know if that code is working properly. But anyway, so now the spatial partition's actually there, right? It doesn't seem to be doing a very good job because I'm not sure what it thinks it's hitting there, right? Wow, that is weird. That is freaky. Okay, so at least now we're getting actual, like, an answer from this thing about the raycast. And so that's a much bigger improvement. That's what I wanted to see, something like that. Because that's like, okay, the raycast is broken, and that's what we should be seeing, right? Not what we were seeing before, which is kind of like a, what is that about? So I'm gonna play around a little bit more. Sorry, it's just like I like where I'm at, and that's just the way it goes sometimes. So you know, you gotta live with it. It's my stream. It's really all you need to know. So anyway, when we come through here and we build the space partition, and then we're gonna do the raycasting. What I want to do is say I don't want to have to rely on those p-values. I just want to use the t-value here. And since we already had to do for that anyway, what I want to do is let the people on the outside do the hit p detection of ray origin plus t-ray. Because if you look at that, it has to actually do the computation. So there's no point in us doing that computation. That's just dumb. Like, we don't need that ever. So if we moved that out to where the raycast actually happens, so inside our compute light propagation call, which we're not using right now, but just to keep it so that it is like roughly correct in terms of a sketch of code, in terms of using the positional value where we do like ray.p or whatever, that's going to be this. So that value is going to be ray origin, ray direction times the ray dot t value. So like t hit or something. I don't know. So whatever the t, or I guess t ray is what it was called. I'm going to call it t hit. So in here, what we want to do is record that value. And so instead of using the p value here, we want to actually use the t-ray value instead. So this is actually that and that, so that we've got hit and T hit. I don't know, maybe T, I don't know. Who knows? And then we never compute that thing in here. So we just return the T value, and if you wanted to know where the position is, well, you can do the add, because you can do the add just like we do the add. There's no, that's not harder. And so we might as well give you the maximal amount of information there. And it's also smaller, right? So we have less we have to actually return, which seems like a plus. And then plus we also have the additional, the ability to do like fancy footwork like I just did, where I or like I want to do here, where I don't have to actually use the computation anymore, right? So yeah. Oh crap. All right, I outsmarted myself. So the reason we were doing the hit P is because we had to compute it for this, I guess. So this is because we need to compute the normal, I guess, of the surface for transport, which is kind of a pain in the butt, right? Yeah. So it looks like it's really the hit value that needs to change. And we do want to keep doing the P because we had to do it. I wish we didn't, if I'm honest about it. I don't love it. Oh, that's a hit P, sorry. So, okay. And then we'd get rid of that. And you can compute that on the outside, right? Yeah. So if you look in here, then this would be where we'd compute T hit. And then anyone who is using that has to do it this way. But that's the only difference. Okay. And then in here, we don't have to do this anymore. All of this stuff can go away. And it's just one comparison. So all we have to do is say, if the cast T-ray dot, what was that thing? The U value, or whatever it's called, U32. If the T-ray, oh, well, it's actually an F32, I guess, or an F32. So if the floating point version, or it's probably an E now that I think about it, but if the floating point version of what we hit, the distance away that it was, is less than the light distance, then that means we hit something before we hit the light. And that was all I really wanted to check, right? So is it just E? And then we just have I think everything now is the way it should be. And then now we just have a problem of going back and actually implementing our raycast, right? So something is buggy in the actual raycast. Like this is not correct, obviously. And so when we're actually, like for some reason that light source thinks there's something in the way trying to get to the voxel centers, but those voxel centers don't even remotely look like there's anything in the way to me. And furthermore, I'm not sure, it's like there's something like right here that's blocking it, but there isn't anything, right? So there's something busted about that raycast function, and who knows what it is? I have no idea. So if we look, I don't know that I want to dive into this because we probably just need to draw it. But what I could do, I think we still have a debug line capability built in here, which may help. So if I turned off the lighting temporarily and just looked at the raycasting, we should be able to push a debug line that shows where the raycast actually happened. So, for example, this push debug line here, this could give us that value. If I said cast from the voxel center P out to vox center P plus, or well, actually just get component cast.p0, and we draw like a, I don't know what the heck we're going to draw. We draw a yellow line, right? Then we should now be able to see yellow lines going to the light source from the cast locations. And I should turn the lighting off so we don't have lighting in the way of that. But I don't know why I don't see any lights here or any debug lines. Where's the debug line drawing code? Is that still happening? Guess that's like something to ask. Oh yeah, so this is in the wrong place, right? We need to make this output the lines after we generate them. So this just draws the debug lines. There we go. And now we should be able to get them to show up, although I still don't see them. What's interesting is it like almost works. Like you can see it can't seem to really get past that outside area. And like right there, you can see it sort of is preventing me from seeing down the hallway, right? So it's like only right, it's like there's these weird like bugs where it's introducing. So we definitely just have some kind of weird like SimDebug in the raycast, but it's almost correct. It's like Edward James almost correct. And I'm just not sure what's going on there. I would like to see those lines, and so I want to know why I'm not seeing debug lines anymore. Here's us trying to push that on. Going through the debug line count. Do we have to enable that? Compute light propagation. So solution update debug lines is never set to anything. Which seems bad. I'm not sure how that's supposed to work. I guess I'll just set it. So we're getting a assertion there. So that's like, it's in release mode, so it's not showing us, but you can see the reason for that is this array count is blown out here. So if we look at how many debug lines it supports, you can see it's 4,096. I'm imagining that the reason for that is, unsurprisingly, there's 2 million of them, right? And for those of you just joining us, 2 million lines is actually more than 4,096 lines, so that's a little bit of an issue. What I'm going to do is restrict the casting. Instead of doing it over the whole cube, I'm going to do it only in the hot region. So when we do compute light propagation or whatever, well, it's not, it's actually just in sort of the light computation and light computation. What I'm going to do there for our test in here, I'm going to say, let's go ahead and actually only do it in the region that we're actually going to copy. So if we look at the solution hot corner I dot z, and then we go from there to hot corner z plus hot dim, right? This will only loop over the values that we actually plan to use, and that'll just make it so we're only casting on a 32 by 32 by 32, which we can probably draw the lines for. Well, actually, you know what I could do? We could do an even smaller subset. So maybe what I'll do is, maybe what I'll do is I'll only draw the line in a small subset of them, because it's going to be too many lines anyway. So maybe we'll do it like if x is greater than or equal to solution hot corner I dot x, and y is less or greater than or equal to solution hot corner I dot y, and z like so, right? And then we also say like, and the same thing again, right? So let's take a look at something more like this, where we're going to say, I probably should have done this as part of the cut and paste, but I didn't, which was dumb. So let's say greater than or equal to some kind of a center, like a more centered kernel. So the hot dim over 2, right? This would be sort of the center area. And then what I want to do is say, let's go like 8 in either direction. So it's like we're going to do a 16 by 16 by 16, kind of in the center. Oh, that may be cutting a little close. Let's do 8 by 8 by 8, right? So just in the middle, I'll see if I can get some debug lines just in that like middle region, so I can see what's happening with the raycast there. So there it is, right? There's our raycast. And you can see it raycasting out to the voxel in from this is the debug light that's like hovering over the hero's head there, right? And what I want to do now is I want to like see what does it actually think it's hitting in these cases where it thinks it's hitting something, right? So let's filter the lines out by only things that we think that actually think they hit, right? That actually think that the distance that the ray was able to travel is like less than the distance that the light is from the voxel center of casting. So I'm going to go in here and say, just show me, like only show me rays that we actually think hit something. So that I can see why you seem to think that it's hitting things in places where I don't see anything, right? Okay. So taking a look at that, I guess so it's really confusing. I don't understand what I'm seeing. Because if you look, the lighting that says it's hitting something is like over here. All of these think they hit something, which is correct, because they all hit the floor, right? But like, why am I getting a... oh, is it because of stuff that's just under the floor? I wonder if all we're seeing is just because it's just under the floor a little bit. You think that's possible? I mean, it could be. Let's draw it the other way. So let's draw it from the light source to the cast location, so we can see if that's the case, right? So let's draw it this way instead, which is not really correct. It's not showing you the ray that was actually cast, but I just want to see, it's a more interesting connector line for me. So if we look and we go, here's the light source, here's the places that it hit, right? And I'm wondering if they're just like right there. I guess even that doesn't really tell me kind of what I need to know, does it? So yeah, I guess I don't really know. Maybe this is actually working just fine. And so if you look at what's going on here, really the only problem that I maybe am having is I'm not using the light probes yet. So we're casting from places like inside the floor and counting that against the voxel, right? It's possible. It's possible. I don't know. So maybe we just need to cast from the voxels. And if that's the case, maybe we need to cast from the light probes, right? And I really shouldn't do that now. All right, whatever. I'm going to call it. We're going to go to the Q&A. I'm going to call it. But it's really exciting because now we're at the point where we should be able to actually go cast from the light probes, add the frame persistence back in, and then we're like basically at light transport. We're really close. And then we can see the main thing we've got left that's a kind of unknown is how we're going to encode that as assigned distance field correctly. That's going to take a little bit of doing, right? But we're really close now. All right, let's go ahead and Q&A. Shouldn't world chunk dim in meters use fundamental unit? Yes, it probably should, now that we've verified that that actually works. There's no reason not to. How about increasing the voxel density and see if that reduces the acne? I don't really want to, again, because I want to now make sure that I'm casting in the right place. So what I'd rather do is go start casting from known good locations, and then once we know we're casting from known good locations, see if it's still there, right? Let's see. I'm a big fan, have always been delighted with your grouchy in a good, very good sense. Okay. I believe that this is a very useful quality that allows you to look at things and the world with a sober look. I still can't understand how to develop this quality in myself. Can you advise something, a book, production, programming, work as a web developer? If you do not mind the time, please give a detailed answer. Thank you. So I would say that it's more of like just a personality trait that you probably either have or don't have, and I don't know that you necessarily want to develop it if you don't have it, because it leads to a very frustrating existence, is one way to say it. Essentially, where the grumpiness comes from is, here's what I would say. fundamentally speaking, your mental model of the world, as you get better at doing something, there are two ways that your natural reaction to seeing other people do it worse than you for what appears to be no reason, how you internalize that. And everyone kind of has to manage it to a certain degree, because as you get better at anything, even if you're never that good at it, just the fact that you're getting better at it at all means you're better than the person who hasn't like practiced it at all, right? So you're always going to be better than someone a lot of the times, and you're going to see people doing stuff that you know how to do better, right? As you get good at anything. Even if you never get really good, it doesn't matter, right? Just getting good at all. So some people internalize that as kind of like an egotism or an arrogance of the form like, I'm really awesome, right? And so the better they get at something, the more they think they're awesome. Other people internalize that as, why is everyone else stupid, right? So they continue to think of themselves as average, and they think of other people as below average. Whereas other people continue to think of other people as average and themselves as above average. And as far as I can tell, this is just automatic. It does it like, this is just what will happen to people, and that one of those two things will occur. And then your natural disposition will either be that you're a grouch, which is my case, and that's when you think of other people as being stupid because they're not doing something as well as you think you could do it. Even if the correct answer is that that's just because you spent the time getting good at something and they haven't done that yet, right? Or you're a dick, right? And you're just someone who thinks you're awesome all the time and that everyone else is not as good as you because you're special, right? Neither are great, right? I mean, there's a reason that people don't have a positive opinion of people who are grouchy or dicks all the time. But I think that's just kind of the natural brain chemistry response goes one of those two ways. I don't know what determines it, right? And so you kind of want to develop mental techniques to avoid that being a problem. Like you want to try to be conscious of these natural tendencies and then not do them, to the extent that you want to not be a grouch all the time, or you don't want to be a dick all the time, right? The problem is sometimes you end up in a situation where it's just relentless, right? And this is the problem that I find the world in these days, where literally it's not just a little bit of the world doing things that are kind of incredibly stupid all the time. It's like all the time, right? Everything you use, like everything you touch is like incredibly low quality, right? Compared to what you think should roughly be the case. And then it just becomes like, I would like to not be grouchy about stuff, and I'd like to kind of have a more positive framing on things a lot of the time, and I just can't. It like overwhelms me, right? And so that's not a good thing. And similarly, I think other people who want to think of themselves as hotshots or awesome or whatever would have a pretty easy time doing that in today's world, because if you become even a slightly good programmer, everyone is way worse than you, right? So if your jam is feeling really good about yourself, well, now's a good time to do it, I guess I would say. But for those of us who just feel bad about the world when it's doing poorly, it's not rewarding and it doesn't really make you feel good, right? You get no positive I guess all I'm trying to say is some people will feel better about themselves when they see other people doing things stupid and they know how they would do them correctly. Other people just feel bad because they think the world is crap at that point. I am in the latter category. So the more I learn about something, the more I think everyone is stupid, the more I feel scared and unhappy. Rather than feeling good about myself, I feel bad about the state of the world and get scared, right? So that's just what happens, and you can't change it. I couldn't suddenly decide to be a dick all the time instead of being grouch all the time, because your brain just, I think, just does one or the other. And then what you have to do is figure out how to not do that thing if you want to be happy, right? You have to figure out how to not be a grouch if you're someone who feels scared about the world when you see people doing things stupid, or if you're an arrogant, if you go the arrogant direction and think you're awesome, you need to tone it down, right? You need to figure out how to stop thinking those thoughts and think more about how to just like be happy and not rub people the wrong way because you're being a dick, right? Instead of rubbing people the wrong way because you're being a grouch. I don't have an answer to how to solve that problem. If I did, I would do it, right? You're asking the opposite, which is how to become a grouch or a dick. And I'm not sure I think it's a good idea to do that. Like, if you're already in the standpoint of not having a visceral chemical reaction to people being stupid, I don't know that you want to gain that, because there's probably ways you can get the good part of it, which is driving yourself to be better. That's the good part of thinking things are crap, is you try to work towards improving them. Or vice versa, right? If you're going the arrogant route or the egotism route, it's driving yourself to be better than everybody else, right? And those are both good, right? They both you thinking everything sucks and you have to do something to fix it, or you wanting to be better than everyone, so you drive yourself to be better than everyone, right? Those are both good drives because they help you get better. But the problem is they both lead to unhappiness, right, in different ways, because in one way you think the world is awful all the time, and in the other way you become insufferable, right? And in both cases, people don't like it, right? I mean, nobody wants to sit around listening to how awesome you are, and nobody wants to sit around listening to how awful the world is. So no matter which way you go, it's not great, right? So what I would say about it in general is the ideal situation, like if you could just tune your brain chemistry perfectly, what you would probably want to do is be able to possess the quality of looking at the world and realizing how much it sucked without it having an effect on you somehow. So like you could see how we're doing all these things wrong and want to try and fix them, but without you feeling the negative feelings that come with that. Or in the opposite case, which I can't speak as much to because I usually don't get a positive feeling for feeling like I did something better than other people. I get the opposite. When I feel like I did something better than someone else, I feel bad about the other people. Like I have a negative feeling about them, not a positive feeling about me, right? So I can talk more about that one as from a visceral experience because that's what I experience. And somebody who was more on the egotistical side of things and felt positive about themselves rather than negative about other people. Again, same basic idea. It just manifests itself in two different attitudes, right? I don't know what the best way of toning down that is, because again, still bad, but it's you end up with a different thing. You're not sitting around telling everyone else how bad they are, but you are sitting around telling everyone else how awesome you are, and that's also kind of insufferable, right? So anyway, the ideal thing, if you could do it somehow, would be to have the outlook that is all of the stuff that we're doing now can always be better, and we could be much better than we are right now. Like we are definitely not performing up to our potential, and you know that and you can see it, right? It would be great if you could develop that without having one of those other two feelings, right? And I'm not sure how to do that, because if I was sure how to do that, I would just do it, because you will be a happier person. Just for your own good, right? Even if you don't care about other people at all, which I guess I probably don't. Just your own, just purely selfishly, right? You will be in a better mood, I think, most of the time, at least for the grouchy people, speaking for me. If you're someone who feels grouchy when you see people not doing something very well, you would be happier if you didn't have those negative emotions. you don't care about the other people at all. You don't care what they think of you. You don't care like whether they think you're a good person or any of that stuff. You just forget it. You don't care. You're still unhappy because you're sitting around going, wow, the world is just totally screwed. Like, we can't learn anything. We're dumb. We make the same mistakes over and over again. Even though there's obvious information, people are always rejecting science on every part of the political spectrum these days just completely rejects the scientific method and nobody uses it, right? Programming, we don't use it. Like, nobody actually tries to do a good job, right? We're just like, screw it, forget it. We don't care. We're losing all of our knowledge. We're losing all our abilities, and society just bumbles forward by the fact that systems that are actually working take a long time to break. And then eventually they just will, and then nobody has power in California and everything else, right? We're all driving around in Mad Max mobiles, like hitting each other with long spears from the back of a 4x4, right? And so I don't know how you develop that like perfect harmony of knowing we need to do things better, actively working towards knowing things better, but not letting the negative emotions affect you. I don't know how you do that. In a world where things are at least somewhat getting better, I think it's easier to do. And what I can say is that when I was younger, things always felt really positive to me. And part of that is obviously because I had not learned as much. So the more naive you are, the less you see the problems in what people are doing. So that's definitely true, because as you learn more, you are more critical of the things that you see, because you have more capacity to be. But another part of it was in general, like the industry that I cared about, which is computing, everyone really was better than me. Not just at that time, but possibly today even, right? Like, the great programmers of that time period were very numerous compared to the average. And in a random sampling of game developers from like 1992, I would say that the me of today would probably not be very good, right? Like, so like, I maybe am fooling myself, but I actually think that a lot of what happened is not me getting particularly much better at programming, but rather I think the world got a lot worse at programming, like a lot worse. And so what I perceive to have happened over the past, say, 20 years or so is that I got a little better, for sure. Like, I am always improving. But I never really got that good. I'm still kind of... I mean, there's a lot of things I do wrong every day, and I know what they are, right? And I still make a lot of mistakes all the time. It still takes me way too long to do things, and it still takes me like sometimes years to explore a problem and come to the correct solution. And like the whole world just like slid past me, like in a huge way, right? So now I look and I go like, what the heck? Like, I drop in to like do some web programming stuff, and like I feel like our website is like far and away better than like 90% of the things that I use. And I am a rank amateur at that. I have no experience, right? What is going on? Like, if I had dropped into some other field of programming in 1992 and tried to do something, in 6 months I would be a nobody. Like, I wouldn't be able to put up anything of value, really, right? And like, that just makes me feel horrible. It does not make me feel like I'm good at programming. It makes me feel terrified at like how bad the state of things is, and I just get like horrified by it, right? And I don't think you want that in your life. I really don't think you do. I don't know how to say it any other way, but it's just like, it's terrifying. Like, you don't want to feel good about your programming in that way. Like, I felt so much better when everyone was better than me. And if I really thought I was a very good programmer right now, I would be okay with the fact that I'm feeling that way about it, but I didn't get much better. Like we have a serious problem. That's all I can say. Like, we have a really serious problem. The kinds of people that I randomly interacted with in programming in like the early 90s or late 80s, the average case was so much better than it is right now that it is absolutely terrifying to me. Like, it's absolutely terrifying. So I don't think you want that feeling. I really don't think you do. I mean, it really feels horrible. It doesn't feel good. Maybe if you're the kind of person who goes the other way and you just become an egotistical maniac, maybe that feels great. To be such a big fish in such a small pond, which I think a lot of people could achieve these days. If you put your mind to it, you can become a better programmer than 80% of the people who work at Facebook or something, probably, right? Like, maybe go ahead and do it if you think you're that person. If you think that's the natural, because man, you'll feel so good about yourself every day. But if you think you're the kind of person who just feels bad about the world, don't do it. Like, don't learn that behavior. Like, if you don't have it in you to have those feelings, by default, don't gain them. Like, don't do that. I don't know. I wish I had something constructive to say. It's an excellent question that you asked, which is, how do you develop that sort of cynicism that allows you to say, we need to do this better because we know we can, and we need to focus on all of these flaws, because that's a fundamental engineering mindset, and I don't think you get great engineers who can't do that. Like, it's obvious to me that every great engineer I've ever met is able to focus on flaws and say, how do we move this forward? But there are times in humanity's history where being that kind of person feels okay, and there's times when it doesn't, and I think now is a time when it really definitely very much doesn't. Like, it is just a horribly miserable existence, is I guess what I would say. And like, don't do it on purpose. Since I'm doing it in C, did you make your website also in C? And if so, is it possible to build an entire website from scratch in plain C using no libraries too? Yes. So I did build our entire website in C. It's basically an offline content management system because I don't put the machines on the web here at Molly Rocket. I just have like one machine that's like a crap machine that's made for doing web uploads, and that's plugged into the net, and it does the streaming here. And everything else is disconnected. And so I basically have a CMS that I wrote in C. You feed data into it on one side, like images and Markdown basically, and stuff that you want as like the content for your website. There's a little animation encoding thing, right, for like this stuff, right? And it just knows about a lot of things. Like, it knows like, oh, okay, how do these things frame, and how do I automatically make stuff that maintains aspect ratios, like that sort of stuff. And it understands all these things. So you just basically give it like, here's roughly what I want to have, and it takes all of that ingress and it just spits out a static blob basically, right? So it like hashes all the binary data and figures out like which of it has to be updated and which of it doesn't, and puts those into like permanent things so they can be marked as cache always and that sort of stuff. It dumps all that stuff out, and it puts it into a ready to distribute format for Fastly, or sorry, for Firebase. Fastly is the thing that runs Firebase at the CMS, CDN level. And then all I do is I just bulk upload that whenever I want to update the website. And I would love to run rsync, but of course, Firebase can't use rsync. It uses node.js. So updating our website, despite the fact that only like 3 HTML files have changed, still takes frickin' 5 minutes because the people who wrote Firebase don't know what rsync is, right? Like, problem that has been solved since 1987 or something like that. But there's the grouch again. Krub, do you ever try and measure how much of your current Outlook is affected by rose-tinted memories? There were great things about using computers in 1992, but I remember having to constantly do things like mess with hymem.sys to try and get the most basic things working. Not arguing that the current state of things isn't woeful. So, yeah, I guess what I would say is I don't think there's really any rose-tinted glasses at all. And the reason that I say that is because when I think of the heyday, right, like I think of using the Amiga 500 or something like that, and I have an Amiga 2000 here, and I occasionally boot it up, and it's like the best thing I've ever used, right? And sure, there's all kinds of problems with it. Like, does it have all the features that Windows 10 has? Like, no, of course not, right? So I'm not trying to make that comparison at all. But when you look at what they did on an Amiga 1000 with a 68K and 512K of RAM, and you look at what Microsoft is shipping today with a PC running at 4 gigahertz, like all core, with 8 cores and hyperthreading and 32 gigabytes of memory and a graphics card with its own 4 gigabytes of memory, and. It's just, it boggles the mind how pathetic the code is today. It's just garbage, and it doesn't do anything else, really. The number of features I actually interact with on Windows 10 is slightly, like a fraction more than what I did day to day on my Amiga 3000. Which I don't have anymore, unfortunately. I've got a 2000 I grabbed from somebody who was throwing it out. I sold my Amiga 3000 to buy a PC when the Amigas kind of went out of production, really, and you couldn't really stay on that lineage anymore. I wish if I was a rich person back then, I never would have gotten rid of it, right? But you can usually only afford one computer back in those days. I mean, they were thousands of dollars. So, some people couldn't afford them at all. And those who could, you could, unless you were really wealthy, you can only afford one. So anyway, I really don't think there's any rose-colored glasses, man. I mean, it's true that adjusting like PC memory was a pain in the butt. But I mean, so, yeah, there were some problems with it. When I plugged in the mouse, it pretty much always worked. My Linux machine, the mouse just doesn't work sometimes. That's it, right? So, and I have no way to fix it, ever. No chance. Hymem.sys was pretty easy to learn. It's only a few parameters, and once you knew them, right? My machine never ran an update. It didn't interrupt me in the middle of playing the original Doom to just make a few quick updates, right? There weren't all these background services running. They don't know what they are. There were no security holes because, hey, guess what? Nothing is running, right? So it was pretty basic at the time. And if you wanted to get a virus on your machine, you had to actually take a floppy disk and put it in the drive that had a virus on it. You couldn't just get one because the thing is sitting around and Microsoft doesn't know what they're doing, right? I don't know. Like, it's a disaster now. I feel like it's a complete mess, and it's not. It's just getting worse and worse and worse. The number of things that we've gained is not even close to what it should have been, right? Goban says, Handmade Hero, I feel like this was a pretty recent shift in the zeitgeist too. I remember just 5, 10 years ago, everyone was much more excited about tech. I don't know if 5 or 10 years ago is enough far back, but yeah, like, I mean, Windows was at least until like Vista, like Windows was actually all right too, like, and sometimes things were getting better, GPUs were getting better, right, and we were doing stuff, and I don't know, right? Which Windows is the best version? Oh, that's easy. NT351. Yeah, hands down. NT351 is the best version of Windows that's ever been, ever will be. Internalization is about grouchiness, but when you do something, you do it qualitatively because you know what quality is. It's cool from a programmer's point of view. That's all I wanted to say. Yeah, I mean, people have drives that drive them to do things better than they need to, right? And it's true that a lot of people do that. And, you know, like, and it's definitely a beneficial character trait for doing better work, right? Like, I know that I'm a much better programmer than I would have been because I get angry with myself when I think something isn't right, and when I think I could do better, right? And I know that getting angry with myself like that is what makes me go further than I would have gotten if I was just didn't have those negative emotions. If I didn't feel badly about myself all the time, I wouldn't get better like that. If I wasn't like, this was stupid, you did this dumb, right? And so I don't deny that it's valuable to have that character trait in certain circumstances. The problem is when the world goes into decline, it's terrifying. That's the cost, right? That's the cost. And that's like the past 20 years, let's say, 15 years maybe. That's the cost. And and it's not good, right? It does not feel good at all. Brian says, the state of programming is pretty sad. I was doing some investigating the other day and needed to use process monitor to spy on devenv. Randomly looking around, I noticed a big number of events sequentially all calling read file. I noticed devenv loading 180k byte config file in 42 calls, each reading 4k chunks from the file, setting the offset every time. So you should be happy. I feel like devenv oftentimes loads things in 1 byte chunks from files. So the 4k is a big improvement, Brian. I would say that one of these days I need to do a stream from an old machine. I think I've got one that has old devenv. I would like to show just how bad Visual Studio has gotten. I think I have a machine that still has Visual Studio like 5 on there. And I'd like to run it and just show you what using a debugger is like. It's instant. And this is on a machine that runs at 1/20th the speed of a modern machine. So this machine is 20 times faster than the machine I'll demo on, and stepping through code in Visual Studio is several orders of magnitude slower, right? How did we get here? I don't know. And more so because I come from a place where I feel horrible about those sorts of things. Viscerally, I don't understand why the people making these things don't feel horrible about themselves. It's hard for me to wrap my head around that. Like, I realize that it's just, that's because it's the way that my brain works and other people's brains don't work that way. But like, how does the team that makes Visual Studio not feel absolutely horrible about themselves every day? I would just be a wreck like, I would just be horrified about my own self every day. And yet they clearly don't, because they don't fix any of it, right? Like, it would be eating at me so much that I knew that I'd taken something that ran in real time and made it take several seconds, and that was my fault. Like, I just feel horrible about that sort of stuff. And that's why, like, I'm always, like, when I release something into the world, I try to make it okay. I write plenty of crappy code, but I keep it internal, right? Um, I try to keep that only for my dev, only for my internal process. And even that, I feel bad about sometimes. Like I've said before, some things that I've written that were meant to just be for me, and that are pretty crappy, are things that still get used as part of the dev process at like RAD or something, right? And I feel bad about that, even though I kind of don't feel like that's my fault, because someone else should have done something about that. Those were supposed to be little tools for me, right, to use. But sometimes tools that you thought were just a little simple something take on a life of their own, right? And at that point, it's like, oh crap, like this was never intended to be good, and now it's actually getting used. But I don't usually beat myself up about that, because I'm like, that's your fault, man. I didn't sell you this. Like, you didn't pay me to do this, right? This was something I had to do quickly in the course of some of the thing I was working on. And if you want to use it, that's your decision, right? So I don't feel that bad about that. But if I'm like selling something like Dev Studio for $1,000 or whatever the heck a license cost, and I like screw it up that badly, I would feel horrible, right? I felt horrible when I thought that the boat glitch was my fault in the witness, right? And it turned out it wasn't, thankfully. But like, even just a little thing like that gets by me, and I feel terrible because it's my fault, right? And I still even felt a little bit bad, because I was like, well, if I had actually gone on this project full time, which I didn't do at the end of the witness, I wasn't full time in it. I'm like, I would have caught that, because I would have gone and checked, and I could have done that, right? And so in a way, while I didn't feel like it was my fault because it wasn't my bug, I could have fixed it, right? Because if I had been on full time, I would have found that, I bet. And so, I still feel bad about that. What's one thing in programming or tech that can excite you and you think is an improvement? Well, I don't really know of any software things at the moment, except for maybe the work that John Blow is doing on his new language. So, I don't know what it will turn out to be in the end, but I just feel like it's the only language development effort that I've seen so far where it seems like the person has any idea what they're doing, right? And that's kind of refreshing, because especially because John has created effectively two whole game architectures. They're related, like Braid and the Witnesser have some similar architectural features to them, but that shipped incredibly impressive things. I feel like that kind of perspective is something that most people who develop languages just don't have. And so I'm pretty excited to see what ends up happening with it. It may still be no good, everything is difficult, and you never know if something will succeed. But I feel like if I had to put money on it, I would say that it's the only language probably in development right now that I'm excited to see what happens, because I feel like it's the only one where the person behind it who actually has done the kinds of large-scale architecture successfully that I think you need to have done in order to actually be able to make good language design decisions, right? Because a lot of other languages are just people making language design decisions without that perspective. They have never shipped something on the scale of the witness that they architected themselves, right? So I'm pretty interested to see what's going to happen with that. And I don't know. If I had to pick something other than JI, I mean, one thing that I was excited about recently was Charles and Fabian making the OODLE compressor. I mean, they made some advances in compression technology that are, you know, I don't think anyone even thought were necessarily possible. Like, I mean, nobody had really made a advancement in compression technology for quite some time, and they come along with this thing that just totally destroys like everything that came before it. And that's pretty exciting to me. Again, because these are just examples of where I can like look up to somebody who's doing something that I know is much better than anything I would do, right? Like I know the OODLE compressor is probably something that if I wanted to do something of that caliber, it would take years of study. And I might just not be good enough to do it, right? And it's inspiring to see that occasionally because you almost never see it anymore. Most of the things people produce are just garbage, and it's not impressive. And I don't want to make it. Like I don't want to be that way, right? And so when you see something that you go like, wow, like the people who made this were just amazing, and they were so on top of it, and they just absolutely crushed it. I feel like that's pretty inspiring too, because you want to be seeing people make things that are beyond your capability, right? You don't want to constantly be looking around and seeing only things that you feel like are not even at the level you could just sit down and do, even though it's not your area of expertise, right? And so when you see people who have specialized in something and they go and do this thing that's just like way better than what you would have any idea how to do, that's really inspiring because it's like lets you know that there are people like pushing boundaries in directions that are further than you can conceive. You know what I mean? And you want to feel that way. And like in terms of software, I can't think of a lot of things like that. You know, like the OODLE compressor is one. But you know, I think I would be hard pressed to think of another one. There probably is one out there. I just don't know. I don't have anything offhand. But the OODLE compressor is definitely one where I think like that was just like a demonstration of skill that I found very impressive. I think I upset you with that question. I'm sorry. You didn't upset me with the question. It's a state of upsetness with the world that is just lingering, and it just happens to be a question where that was the topic of the question, right? Do you have any advice for applying for AAA engineering jobs? I've worked on a few indie titles, porting them to consoles, most Unity games. I think a lack of C++ work experience is hurting me, but it's hard to get that work experience without previous C++ experience. Any advice? Not really. I mean, I think you want to have some spare time projects probably. If you cannot get a C++ job right now, I don't know how you could really get one with no experience. It'd probably be pretty tough. Entry-level C++ work is hard to come by, I think, in the game industry anyway. But I don't really know. I don't apply for AAA engineering jobs, obviously. Um, so I'm not sure how that market looks. There may be places for junior programmers to get into it where there's like a sort of a bridge there. But I guess I would ask the question: when you say porting a Unity game to a console, what does that mean? So, because doesn't Unity just run on consoles? So that's not C++ experience. What does that mean? I was trying to figure out where you're coming from exactly, because then I could kind of maybe. Do you do anything specific to motivate yourself in the world of awful software? Well, no, because it's not really about motivation or not. I just enjoy programming, so I do it every day pretty much by default, and if I go for too many days without programming, I just get sort of forlorn, really. So I never really have to motivate myself to program. It's always just going to happen. It's more of the feeling that you get and the psychological toll that takes is the problem, not that it's demotivating. It doesn't ever demotivates me. It just makes me terrified all the time, right? What I can say is that, like, if there was, I do think it creates an opportunity in the world, though. And, I don't think that opportunity is ever going to be taken. But if you were some kind of a enterprising small country out there somewhere, right? And you were like, okay, we are like the government of, I don't know. I'm not sure who this would ever be in reality, but you're the government of Qatar, let's say. And you just decide one day that you're going to be like this enlightened government and you're going to like try and create the next world economy. Because why not? Before the oil money runs out. I don't know. If you actually set up a thing where it's like, okay, we're going to take a government and we're going to say that, like, we guarantee certain things, like, we're going to create a environment where people are 100% encouraged to be like scientific about everything, and our entire government will be run this way. So everything has to be based on repeatable premises, and we're not going to do any of the weird liberal arts self-esteem complete garbage that like the US does nowadays, or that a lot of places do. We're actually going to be like, we're creating a place primarily for people who want to focus on excellence and never be sort of like, told that their primary goal is something else. I mean, I'd move there tomorrow, right? Like, I would love to know that everything in that society was going to run like on that premise, right? But short of something like that, where someone actually creates, and it's not unprecedented. There's been plenty. You look at even the founding of the U.S. or countries that followed suit afterwards, right? There's tons of times when there's been shifts in the way that people framed their societies and how they were going to work, right? And so there's nothing that says that someone brilliant somewhere who's smarter than me and knows how to figure this crap out, John Madison 2.0 or something, um, figures out how to structure a society so that people are driven to always do things well and be focused on excellence always, and everything else is not part of your societal fabric, right? I feel like it wouldn't be long before literally all the top talent wants to be with you, right? I mean, I would be trying to convince them I was good at something so that they would let me in, because the feeling of being surrounded by people who are all trying to be good, I mean, these days I feel the opposite. I feel like I'm surrounded pretty much entirely, other than like the small group of people who I know, I feel like I'm just surrounded by people who couldn't care less. Like everything else is more important to them than quality, right? Than excelling, than pushing forward, right? And being better. I don't feel like it's even on their radar, right? And you can see that manifested everywhere you go. When was the last time you saw a TED Talk called Focusing on Excellence? Like, how do we make people want to focus on excellence? I don't know. Is there one? Maybe there was. There's hundreds of these things are passed around. No one ever passes that one around, if there was one, right? When was the last time you saw a political debate where they were like, you know what the problem with our country is right now? No one cares about doing things well. Nowhere to be found, right? Not on the table. Not interesting. When was the last time there was what's the word I'm looking for? Not really an incident, but like national news focused, like college campus incident, who knows what, where the primary flashpoint was, are we focusing on excellence? Are we trying to be excellent about things? When was the last time that was a huge issue in a public schooling debate? Are we driving all of our children to try and be excellent at the things they do, right? It's like never. Everything else is more important than that, right? Everything else, at least where I live and probably where you live too, is not about being good. We've like somehow developed a culture where the idea is about everything other than actually doing a good job. And I think that has consequences in the long run if there's ever competition. And that's why I say it creates kind of a pretty big opportunity. And it certainly creates a big opportunity for adversaries, you know, if larger sort of competing countries, if Russia or China or, you know, large industrial bases got serious about competing with the US, which, you know, China maybe is kind of in that position to a large extent. I don't think it would be that hard. Focus on excellence and you'll be past the US in a few decades, right? Because no one here cares, not even a little bit. And it's never talked about, and there's no money in it. And there are many, 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 many people all over the place whose primary goal every day is something opposite, or at least tangential, right? So there's huge amounts of money and effort and people spending their time trying to get everyone to focus on things that are not that. And there's nobody, like almost nobody, spending their time trying to get people to focus on that. And so what do you think is going to happen, right? Are you describing technocracy? I don't know if I'm describing technocracy. I'm just describing a place where you center your cultural values around excellence. That's all I'm describing, right? And like I said, if I knew how to do it, I'd try to get someone to do it, right? I mean, I'd try to be James Madison 2.0 if I thought that I was that good, but I'm not. I don't know, right? What the hell do I know? I'm a software engineer. I don't know anything about how you run a society, right? I am simply talking about a symptom, right? I'm talking about a symptom of a problem, which is that, a symptom that I can observe. And it's a symptom of something that I don't know what it is or why it happens or how you would prevent it, right? It's similar to some kind of disease. You know, you see that someone has hives all over their body. Well, there's hives, right? But you don't know how they got there. And so that's kind of, what the world looks like to me. I can see that we no longer care about doing a good job and getting better at things. That's obvious, but why, right? I can point to a lot of people who make it their mission in life to distract people from that, but I don't know why they are either, right? So I know that they are and that they don't care, but I don't know why they don't care, right? And I can come up with all sorts of hypotheses, but really I'm just engaging in pop psychology at that point, and who knows? So I think, unfortunately, it's left to people smarter and more more in tune to the way societies function to solve that problem if it ever does get solved. One way to force that idea of excellence is through some form of authoritarianism, but many wouldn't like that. Well, and authoritarianism is not really that helpful because it's just as likely to go sour, right? I mean, this is why dictatorships are problematic, because maybe you create a dictatorship and it's great for a little while when you're running things the way that dictator's running them because they're really good, but they die, right? And now someone succeeds them, and maybe they're not so good, right? And so one of the problems is that you need more than just a way of getting people to focus on excellence for a little while through coercion or through some kind of a dictatorial or authoritarian regime. That's not stable. Like, maybe you'll succeed for a little while, but you won't succeed forever. And so really what you're talking about, or at least what I would see is the great sort of achievement, if you were ever able to do it, was how do you create a culture where everyone feels compelled to drive towards excellence, right? And I really don't know how you do that, right? I don't know. Yeah, long Boolean, yeah. I mean, that's a good option, right? Define excellence to be whatever it is we're doing right now, and then we can kind of go home, right? So, yeah, I mean, I couldn't tell you. I don't know. It's interesting to theorize about, but it's just I don't have any answers, right? We've figured out a lot of things. If you look at capitalism, one way of looking at that is like, oh, so that was a way of figuring out how to assign wealth to people who accomplished something, right? And that's really good because it does drive a lot of things forward to a certain extent. But the problem is it's still based on the wealth, right? So what you end up seeing happen with systems that are using capitalism is once you have a way of generating the wealth, you no longer care about the excellence, right? And that's where you end up having to have antitrust law and all these sorts of things, because once you have monopoly, you can just extract the wealth. You can bundle things together, and then some things can be good and some things bad, and now you don't have to worry, blah, blah, blah. If there's a glut or a gold rush situation, then there's no need for excellence at all. So, we found some tricks, and capitalism was a really good one, right? I think capitalism was a great idea. It was brilliant, right? The question is, how do you get better than that? And, you see a lot of time nowadays people saying socialism is a good idea or something. It's okay, come on. We need to be coming up with something better than what we've had, right? Figure out what's the thing after capitalism. Figure it out. It's not socialism. That was the thing we had before, right? What's next? Give me the next version. There's got to be a better way of making it so that people are constantly motivated to be good, right? And I know there's a way to do it, right? It can't be that capitalism was the best answer we had. There has to be a better one, right? And like I said, it's not my recipe, so I don't know what it is. But it can't be that after only 10,000 years, I don't know how long we've been screwing with this stuff. It can't be that we hit the maximum. There's got to be a way to get past it, right? To a place where people are driven more towards excellence. And also driven towards excellence, like one of the really big problems that I see with like capitalism, for example, is it also doesn't have a way to account for the problem of driving towards excellence locally as opposed to laterally. So for example, if you have someone who is the best janitor in the world, they are not making very much money, right? And this creates a problem because what it means is anyone who's good enough to be the greatest janitor in the world probably could have gone and done something else, and they will, because they'll get paid more, right? And so you end up with this problem of the industries that are currently able to extract the most money out of the economy, those get all the good people, and everything else, you have to do it just because you love it or something, right? And there's constant pressure to not do it, to do something else because you would have gotten paid better, right? And so there's also like that kind of that lateral allocation problem that capitalism suffers for, that pretty much guarantees that anybody who works in certain sectors, even if they are excellent at their job, either doesn't feel good about it because society doesn't value them, or has no incentive to excel, even if they could have, right? And so there's a lot of problems there too, and that was never really addressed with capitalism. Now there's some good aspects of that in capitalism because it means that in theory it allocates your quote unquote best people to the most important place. Maybe, but come on now, right? Like it has a pretty high cost for doing that. You know what I'm saying? And you end up with ridiculous stuff like 3,000 people working on the back end for like Twitter or something, getting huge amounts of money when really that could have been done by 20 people. And what are we burning all this money for? We could have paid all the janitors a lot of money and gotten really awesome fucking janitors, right? Really awesome janitors, right? So there's a problem with the societal value of things. And so when I think about excellence, I'm thinking everybody in every position should be driven to be excellent at what they do. And we definitely haven't developed a system that makes that work. We place a much higher premium on which job you're doing than how well you're doing it. A super crappy doctor makes way more money than the world's best janitor. And to me, that's not right. To me, that yields a worse world outcome than what I would have preferred, right? And so again, like, and obviously, like everything factors into this. It's not just your economic system; it's your religion, it's your schooling. Like everything plays a part in reinforcing the culture of excellence. We don't have it. I don't know why. I don't know how to fix it. It's just sad. That's all. And it's nobody's fault. It's just we haven't come up with a better system. And yeah, like I said, capitalism versus socialism or things like that, they're small arguments. They're arguments of if you have a small outlook on the world. It's you saying there's nothing better than what has already been tried, right? And I don't fundamentally believe that. Like, I believe we can do better than capitalism and socialism and a combination of the two. Like, I think we can do better than what we're doing. But of course, that's my nature, like seeing that things are probably not as good because, if they were actually optimal, we would have been living with them for hundreds of thousands of years, not thousands, right? So, all right, this has been a very long and ridiculously philosophical stream where, what's the point is what I say, right? Like, I mean, I don't have any answers, so I'm just not sure what the point is. of talking about it. It's outside my field of expertise, and I don't have anything to suggest other than to tell you that I'm depressed about it, and I'm not sure what good it does to let everyone know that I'm depressed about it, right? Unless you all want to be depressed too. All right, thank you everyone for joining me for this episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to pre-order the game on handmadehero.org, or I should say, if you would like to follow the source code, you can pre-order the game at handmadehero.org, and it comes with the source code, so you can follow with it on your machine. I don't have any answer as to how you make the world try to strive for bigger and better accomplishments, but I do have a way for you to get the source code, and that is it. And then, hey, you can take my source code and strive for bigger and better accomplishments. There is not a single piece of Handmade Hero that I don't think could be done better than we're doing it right now, and so have at it, man. There is always something to improve in pretty much everything, except the few very small, very specific pieces of things. And so, you know, maybe you can get a little bit of a drive to excellence going, find something in Handmade Hero that currently sucks, and make it good. I guarantee you there's tons of parts you can do that with. We mention them all the time, so, you know, give it a shot. I'll be back here probably next week. I haven't posted a schedule yet. Oh, wait, no, that's not true. I'll probably be off next week. So I'll probably be back here in 2 weeks when we will try to take the ray tracing core and start implementing that across light probes, which will then distribute out to our lighting voxel. And I think that's kind of the last step in the process before we're into tuning mode. Really excited about that. And hopefully we can come up with good ways of mapping those things so we can, so we can have some really, really, really good lighting, which, you know, again, I want the lighting to be excellent because I want everything to be excellent if I can. I hope to see you back here for that in about 2 weeks. Sorry, I won't be here next week. I'm going to be away for the weekend, so I can't stream. But until then, have fun partying, everyone. I'll see you on the internet. Try not to be as depressed as I am about the state of the world. That's about all I got for you. Take it easy, everybody.